Okay, so today I'm going through 2019's one question 3, right? So I've got the paper open here. So let's read the question. This question. So we're gonna read the question, right? The question essentially asks us if I get this integral by essentially rationalizing the denominator, right? Because this is the conjugate of this. So think of a third. Let's just say 1 over 2 minus root 3. To rationalize, we're going to multiply by the conjugate 2 plus root 3 in the numerator and denominator. So we're essentially doing the same thing, but with sine of x. 1 plus sine of x. Okay, so let's get started with the question. So we have define I to be the integral. So pi over, what is it? Pi over 4. 1 over 1 plus sine of x dx. So now we're going to apply a technique. So we're going to multiply both sides by the conjugate 1 minus sine of x. Pi over 4, yeah. For the 0 here. So it's further away. 1 plus, no, 1 minus, my bad. 1 minus sine of x over, so that's going to be different to two squares, right? So we're going to get 1 minus sine squared of x dx. Now, remember Pythagorean identity, we have sine squared of x plus cos squared of x equals 1. 1 minus sine squared of x equals cos squared of x. So we have integral from pi over 4, 0, 1 minus sine of x over cos squared of x dx. Now I can split this fraction. We can use pi over 3, 1 over cos squared of x minus sine of x over cos squared of x dx. Now, remember we have secant defined to be 1 over cos of x. So that implies secant squared is going to be 1 over cos squared of x, which is what we have here. Now this is going to be tan of x, because tan of x is sine of cos, times sec of x, because we still have a cos squared. So that tells us the integral is going to be the integral from pi over 3, pi over 4. Wait, need to get this right. Pi over 4 is 0. Sec squared of x minus tan x. Well, I'll probably write sec first because I'm a normal person. Sec x tan x dx. Now these are standard results, so we get tan of x minus sec of x. Because to differentiate tan x, we get sec squared. To differentiate sec of x, we get sec x tan x. So now we get this result here from the theorem of calculus. So that's going to be 1 minus root 2 minus 1. So we get our answer 2 minus root 2. Okay, so that's the first part of the question done. Now we're going to look at the second part of the question. 1 second. Okay. So we have a similar structure, because we have h1 plus a trig function, and it's 1 on the numerator, right? So that implies we should just try the same technique we did here, but instead. So we're going to write our integral and define the integral to be the integral from pi over 3 to pi over 4, 1 over 1 plus sec of x dx. Now instead of applying the technique we did previously, essentially rationalizing, I think we should manipulate this, because sec of x is obviously 1 over cos of x. We derived that from, when we derived, we learned of that in the first part of the C. So we're going to replace that here. So we have pi over 3 to pi over 4. 1 over 1 plus 1 over cos of x dx. Now we multiply by cos of x, we get the integral from pi over 3 to pi over 4 cos of x over 1 plus cos of x dx. Now I'm going to multiply by the conjugate, which is going to be 1 minus cos of x, pi over 3 pi over 4, cos of x, 1 minus cos of x, over, this is 2 squared, so 1 minus cos squared x dx. Now if we go back here, we can similarly get sine squared of x, because 1 minus cos squared of x. So that tells us the integral equals pi over 3 pi over 4 cos of x minus cos squared of x over sine of x, right? So now we can just split this again. So we get the integral from pi over 3 to pi over 4 cos of x. So we get cos of x over sine squared of x minus cos squared x over sine squared x dx. So this is going to be, so tan of x, right, is sine over cos, sine x over cos of x. And 1 over tan of x equals cotangent of x, cot. So this is a reciprocal, so reciprocal of this is cos over sine, so that's going to be cot, cos of x over sine of x. So we use that here, and we're going to get the integral from pi over 3 to pi over 4. This is going to be cot x, and I'm left with 1 over sine, which is cosec x, minus cot squared of x dx. Now if we go back to our Pythagorean identity, we have this, right? So we divide both sides by sine squared of x. We're going to get 1 plus cot squared of x equals cosec squared of x, right? So rearrange that, we get cot squared x equals cosec squared x minus 1. So we're going to apply that to our integral. So we get this again. This is going to be minus cosec squared x plus 1 dx. These are just now standard results. So we're going to get minus cosec x plus cot of x plus x from pi over 3 to pi over 4. So now we're going to get, let me put this, minus cosec pi over 3 plus cotangent pi over 3 plus pi over 3 minus cosec pi over 4 plus cotangent pi over 4 plus pi over 4 . Okay, so we're going to evaluate this. We're going to get minus 2 root 3 over 3 plus root 3 over 3 plus pi over 3 but minus root 2 plus 1 plus pi over 4. So to simplify this down, we're going to get, so with this simplifies easier. Root 3 over 3. No, minus root 3 over 3, right? No, yeah, minus root 3 over 3 plus pi over 3 minus, well, plus root 2 minus 1 minus pi over 4. Now to make, so we're just going to put the positive terms from first, right? So we're going to get pi over 12 plus root 2 minus 1 minus root 3 over 3, and that's our answer for the second integral. Just waste all the space here, but it doesn't really matter. Okay, so now we're going to go down to the third integral, which is the integral of pi over 3, 0. It's essentially the same integral as this, but we have a square term here, right? So again, that applies to the same technique. So we're going to go back to here. We're going to define I to be the integral from pi over 3, is it? Pi over 3, 0, 1 over 1 plus sine of x squared dx. Apply the same technique we've done by where we multiply by the conjugate. We need 1 minus sine of x squared. Now, here we're going to replace this with cos to the 4x because it's different to 2 squares. But it's both squares, it's moved to the 4. So cos to the 4x dx. Now if we expand out the numerator, we're going to get power of 3, 0, 1 minus 2 sine of x plus sine squared of x over cos to the 4x dx. Similarly, we can split the integral here now. So we get the integral from power of 3, 0, 1 over cos to the 4 minus 2 sine of x over cos to the 4x plus sine squared of x over cos to the 4x dx. Now this is going to be the integral from power of 3, 0. This is obviously going to be sec to the 4x, and this is going to be 2. Sine of cos is tan, so, and then we still have a cos 1 of cos cubed, so it's going to be sec cubed x tan of x. We have 2 obviously there. Now this is going to be sec squared, well tan squared sec squared, right? But so sec squared x tan squared of x, but we're going to hold on to this because if we go back to our Pythagorean, I'm just going to write over here sine squared x plus cos squared of x equals 1. Divide everything by cos this time, we're going to get tan squared of x plus 1 equals sec squared of x. So now we're going to replace this, we get tan squared of x equals sec squared of x minus 1. We replace this back here now. So equal, that's going to be sec squared of x, sec squared of x plus 1. So we sec to the 4x minus sec squared of x. So that tells us, and we simplify this down, right? So we get the integral from power of 3 to 0, 2 sec to the 4x minus 2 sec cubed x tan of x, or minus sec squared of x dx. Okay, so now this is the integral, right? So we can split this into separate integrals. So I'm going to move over here a bit so we have more space. Integral from power of 4, 0. I'm going to put 2 out. Sec to the 4x dx minus 2 lots again. The integral from power of 3, 0. Sec cubed x tan of x dx minus the integral from sec squared of x dx. Okay, so now here, right, we're going to start in simplicity. So we're going to start with the easiest integral of these three, which is obviously this one. I've got my bounds, sorry. Power of 3 and 0. So this is a standard result. We've used it in the first part here. It goes to tan of x. So we're going to have minus, so I'm going to evaluate afterwards, right? So tan of x power of 3, 0. Now here, this is actually a simple integral, but it's not as obvious as the first one. It's reverse Tumor, right? Because since we have sec cubed of x, differentiate this. So we can rewrite as sec x cubed, so we're going to have 3 sec squared x multiplied by the derivative of sec x tan x. So we get 3 sec cubed x tan of x. But in our integral, there's no 3, so we're going to put 1/3. So equals, so we've put 2, 1/3 sec squared x. And this is from pi over 3 and 0. So, okay, so for the final integration, we're gonna rewrite sec of x, sec to 4x, as sec squared x times sec squared x. So this is gonna be our integral, right? So we could do integration by parts here, but I honestly don't think that's the strategy. So we're gonna go back here. We wrote tan x equals sec squared x minus 1. So we're gonna write tan squared x plus 1 equals sec. So we replace one of them here. So it equals, so we're going to have sec squared x tan squared x plus 1 dx. So that gives us sec squared x tan squared x. Plus sec squared x. So sec, now this is a simple integral. So this is going to be tan of x. This is a reverse chain rule. So if we have tan cubed of x, differentiate. So we can write it as tan of x cubed because, yeah, so we have 3 tan squared x. Now multiply derivative of tan, sec squared x. So that tells us we have 3 tan, well, we need 1/3 to get rid of the 3. So you have 1/3 tan squared x, sec squared x. Plus tan of x. So if we combine this, all 3 results here, we have I equals, we need to remember our 2's, so we have, so before we even write that, we're going to replace it, we're going to write it as one expression and simplify it down. So we have tan of x plus 1/3 of, this around my bad, 1/3 tan squared, it doesn't really matter, 1/3 tan squared x sec x. Now here we have 2 1/3 sec cubed x, is it? Yeah. 2 1/3 sec cubed x. For a square bracket here when it in reality it should not be a square bracket. And we have a minus tan of x. And we're not going to evaluate this yet, right? So simplify this down, we get, expanding the brackets, I mean, we get 2 tan x plus 2/3 tan squared x sec squared x minus 2/3 sec cubed x minus tan of x. Simplify this down again, we get tan of x plus 2/3 sec cubed of x minus 2/3, wait, that's a tan, sec cubed of x. Now this is from pi over 3 and 0. So tan pi over 3 is root 3, and then sec pi over 3 is 2. So we're going to get, so in the space, root 3 plus 2/3 root 3 cubed, which is going to be 3 root 3, minus 2 over 3, 2 cubed, which is 8, minus 0, 0, and minus 2 over 3. Without, that's going to be root 3 plus 2 root 3. So 8 16 over 3 minus 16 over 3. Then plus 2/3. So that's going to be simple addition. So we have 3. Simplify that, I get 3 root 3. Not plus, a minus 14 over 3. And that is the end of the question. And thank you for watching. And I hope it's helped.